Hello, my name is Bob D. Hilster and I am your particle model guru. Today's video is on measuring the electron mass. This is part 2 of a series on what the mass of the electron is. If you're new to the TPM, I suggest you watch 3 different videos, the particle model overview, levels of the universe, and 2 gravities. And in particular, 2 gravities comes up quite strongly in the presentation today. Well, in part 1, my video part 1, measuring the mass of the electron, we watched a video. We didn't watch the video, but I was describing the contents of a video where this lady described how to measure the mass of the electron. It's a real old video, but YouTube published it in July 12th of 2015 to make it available to the public. So we're going to continue to look at this one. This is the apparatus that the lady used to measure, and it has a voltmeter. It has a power supply that provides DC and current to the coils. These are 2 coils. And there's an electron gun back here that shoots electrons. And there's a globe that encases the electron gun. And the globe has a little bit of hydrogen to help see the stream of electrons. This is the apparatus used to measure that. Though what I didn't cover last time was a little bit about the coils. These are actually coils specifically designed to give a unique magnetic field. They're called Helmholtz coils after the gentleman who developed them. And of course, it has 2 coils and they're identical. They both have the same number of turns N, and they both have the same current flow through them. The diameter of the coils are 2r, or twice the radius, and the spacing between them is r. And it turns out that this particular arrangement provides a very good magnetic field flow right through, as shown by the arrow. You can see that the flow would have to be this way and out, and the same way here, around this way and out. And down here it's that way and out, and it develops a flow. Now, mainstream claims that the magnetic field is continuous. The particle model has a different model. It's a discontinuous flow of G1 particles. And although from our own perspective, a human perspective, looking at a magnetic field, it appears continuous because there's so many of the G1s. Even though they're discontinuous, it appears to be continuous, but physically it is not. Now, one of the explanations that they give is based on the Lorentz Force. And the Lorentz Force is an equation developed by Heinrich Lorentz. The force is equal to the charge times an electric field, plus the charge times the velocity times the strength of the magnetic field. So there's an electric field, there's a magnetic field, and the sum of the 2 sets up this force field. And yes, those are the right forces required to cause an electron stream to move in a circle inside the globe. I'm not going to go into the details here, just kind of overview of it. Here we have the G1 particle field of the magnetic field coming out of the page towards you. That's the direction of the magnetic field. That's what that circle with the dot means. And then there's an electric field. Well, the electric field is caused by that power supply, which puts a negative voltage on the cathode end of a electron gun and on the positive end. It puts, and that heats the cathode and shoots electrons. This presumably is a screen, and the electrons come out. And it's the overlay of the force field. The force field, electric force field, is caused by a positive and negative charge, which this has, positive and negative charge. The force is in the downward direction, but it pushes the positive charge in the downward direction and pushes the negative one in the up, and we have it going up and around. So it's a combined field between the electric and the magnetic fields, and somehow it generates this vector. They have vector diagrams that show how all that works. I won't go into that, but that is the presumed correct force that they need to cause that circular flow. Now, the Lorentz vectors appear in the video that I showed you before, and this is the first term. Only here it's in terms of energy, not force. Electric field times Q is force, but voltage times Q is energy. So they break it apart, and they take the electric field and equate it to a physical energy, which is 1/2 mv squared, and then they take the magnetic field and they equate it to, again, a physical force. This is force and this is energy. So they split the Lorentz thing and they build these equations this way, and they get the values and do all their math based on the voltage being 100 volts. The current they read is they don't show the current here. They use the current to look up on a chart to find the magnetic field, and that's the magnetic field. And this is that includes the charge. Anyway, do the math. You get the mass of the electron, and you get its velocity. The problem I have with the description is, although it all seems quite logical, there is no physical description. There's no description of what the magnetic force is. We know magnetic force pushes electrons apart, but there's no description of what that is. Electric force can accelerate an electron. They show that over and over again, but there's no description of what it is. They just draw force lines, they draw vectors, and sometimes talk about right-hand rules. But all you know is the direction. They don't give you a physical description. Now, the particle model has two gravities. Gravity 1 keeps the Earth together. It holds air and water and other stuff together around the Earth. It also keeps the moon in orbit. This is the force of acceleration, which is all the way around, just like this. And this force, this gravity force, can cause a circular motion. Gravity 2 does the same thing at the atomic level. It holds the nucleus together, and it keeps the G1 in orbit around the nucleus or around the nucleon. G2 particles act gravitationally with the N1 particle and the G1 particle. But when G1 hits G1s, okay, this is a key point, G1s hit and scatter. And that is, you think of these as two G1 particles come together, they hit, they scatter. That's not gravity, not as individual particles like that. If you want to have an orbit like the moon around the Earth or the G1 around the N1, it has to be gravitational. Okay, so if you're going to control the G1 and make it go in a circle, you got to have G2 gravity. And frankly, there's G1 gravity around this, but Newtonian gravity is ignored. You've got G2 gravity all around the whole thing. In fact, it's the G2 gravity around this whole thing that helps develop this magnetic field that's, well, it's flowing this way. And apparently, because of the construction of this, and this is hard to explain, it's hard to explain the Lorentz force, and with directions and vectors, it's just as difficult to think of a G2 force inside here that would be structured such that you had equal forces here, up and down, in and out, left and right. Left and right doesn't matter in this case, causing the G1 particles to go in a circle. It has to be gravity in order to make that go in circle, according to the TP model. The particle model, the magnetic field is a stream of G1 particles orbiting around it through the Helmholtz coils in this example. Electrons are also G1 particles. So the interaction of the magnetic field with the electrons flowing around is in the form of random collisions. Scattering only causes an intensity decrease. It'll knock, the magnetic field is going to knock the G1 particles out of orbit, and what's going to happen is the intensity is going to decrease. But you don't see that because the electron gun keeps supplying you with more and more electrons, keeping the stream going. The scattering cannot cause a circular flow, so I'm saying magnetic field doesn't do it, not the field itself. But the particle model interaction of G2 gravity with the G1 electron can cause the flow. And what you have is that G2 gravity builds up very nicely around the G1 magnetic flow inside that globe. The magnetic field's coming out of the page, and this is established because, in part, not only in part, but because of that flow of G1 magnetic field inside the globe, and therefore you get these G2 forces around, providing the forces needed to cause a circular orbit. Again, it's a very complex situation, hard to explain specifically how that could possibly happen. But obviously, developing the Helmholtz coils and adjusting the voltages and adjusting the magnetic field is required in order to get it to be that way. The particle has a physical description. The Lorentz force is replaced by G2 gravity, and G2 gravity can cause G1s to orbit. The magnetic force is a high-intensity flow of G1 particles around and through a magnet. Magnets repel each other because of scattering, not because of gravity. G2 gravity generates the magnetic field. As the G2 gravity generates the magnetic field, it also generates a G2 field. It's that the G2 field that causes the magnetic field, but it generates this smaller one inside the globe that controls the flow of the emitted electrons in the circular orbit. It's a physical description. They're particles, discrete particles, and it's not the combination of the electric and magnetic field. It's primarily the G2 field controlling the overall magnetic field, which has a special G2 field inside the globe. Yeah, well, the video was supposed to be about mass, and all I did was explain to you how they explain the flow in circular orbit using their Lorentz force, and I showed you how the particle model does. The mass of in kilograms, they're trying to say the electron has kilogram mass. But Newtonian gravity does not work with an electron. Newtonian gravity does not work with an electron. It works with atoms and molecules, and clusters of atoms and molecules, and we have a standard. We build this thing and we label it with a 1 kilogram value, and we say that's what the standard is, And now the electron mass is being compared to this standard. But this is G1 gravity, G1 mass. It's based on G1 gravity, and G1 gravity doesn't affect the G1 particle the same way. There is no assigned value or standard value for G2 gravity. This is G2 gravity causing the to circulate. Without a standard, I can't assign a value. There has to be work done, some way, some mechanism to define a standard, just like we did for G1 gravity. There has to be a standard for G2 gravity. Mainstream did what they could, and I don't fault them for that. But according to the particle model, you really can't assign a kilogram value to an electron. Conclusion, mainstream has an electric and magnetic fields with no physical explanation, but they have a standard for the kilogram standard, which is for G1 mass that is used to measure the mass of the electron, and they do it this way. They mix the two. The particle model states that the mass of the G1 particle cannot be stated in terms of a kilogram. It has a proposed physical model for the electric and the magnetic fields, but no standard for the mass of the electron, which is the G1 particle. Next time, tune in and I will explain more of the universe using the particle model. Thank you for your attention.